Hey yo, um, I'll level with you real quick. It's 2:15 a.m. Running on fumes, but hang in there with me. I'm back with another math lesson. Um, this one's on simplifying radical expressions. Let's dive right in. Let this be a testament of human determination and resolve. You know, y'all can do this work. The work's worth doing. It always is. Alright, it's the 28th. Got 6 examples that'll hopefully teach you something. Today we're simplifying radical expressions. Alright, 2 learning targets. First, I can simplify a radical expression by adding and or subtracting. Like terms. And see how like terms refers or like applies here with square roots and radicals. 2. So 3 examples related to that, and then second learning target. I can multiply terms that include radicals. Remembering, this is what I'm going to point out, remembering to simplify early and often. Alright. So what do I mean by adding, subtracting like terms with radical expressions? Well, let's look at an example. Simplify. Say the expression is negative 11 times the square root of 21 minus 11 times the square root of 21. Now notice, right, the radicands are the same. So we got kind of a match of values in the square roots. The square roots. So we can combine like terms just like the variables. So really you're just evaluating the difference of negative 11 and 11. Or in other words, adding negative 11 and another negative 11. Subtracting 11 from negative 11. Equivalent ways of saying the same thing. So this is just negative 22 times the square root of 21. So now we're just taking the difference of the numbers in front of the radicals. Simple. But let's say we look at a different example. We're asked to simplify. That looks like a good one. Simplify 2 times the square root of 6. And it's the difference of that and 2 times the square root of 24. Notice at first glance, these aren't like. Right? Like, we couldn't just subtract the 2's and make this like 0 times the different, like, they're just not like terms, so there's no difference to take at this point. But if you learn anything from the last lesson on just simplifying radicals, you'll notice like, perhaps you've done an example like 24, but you're now kind of curious, like, is there a perfect square factor of 24? Well, let's just start looking at factors of 24. 1 times 24, either perfect squares. 2 times 12. No, 3 times 8. 8's perfect. I mean, like, 8 kind of like gives me a hint towards something. 4, 6, 5. That's it. Oh, well, there it is, right? 4 is a perfect square. So this actually simplifies. Using the product rule, we write 2 times the square root of 6 minus 2 times 4 times 6. And now we have a perfect square factor. So we have 2 times the square root of 6 minus 2 times the square root of 4 times the square root of 6. Square root of 4 is 2. This becomes 2 root 6 minus 2 times 2 times square root of 6. Or 2 times the square root of 6 minus 4 square root of 6. Now, those are so alike. So like. Oh my gosh, they're so like. I'd ship them. 2 root 6 and negative 4 root 6. So take the difference of 2 and 4. So we get negative 2 root 6. And that's the solution. Bam. Alright, now one more example. Alright, where at first glance, things don't quite appear to be like. My eraser's not working. Great. I'm just going to cross that out. Alright. Let's say we're asked to simplify. This is why we use pencil, folks. 3 times the square root of 8 plus 3 times the square root of 2. Again, at first glance, not like, but hey, like 8 equals 4 times 2, and 4 is a perfect square. Boom. So this equals, right, let's maintain our proper algebraic form in a vertical format, 4 times 2 plus 3 times the square root of 2. So this ends up becoming 3 times 2, right? You can kind of simplify the radical. Square root of 2 plus 3 times square root of 2. Or 6 root 2 plus 3 root 2. Now we just add up the two numbers to the left of each of those square root 2's, and we have 9 root 2 is the simplified expression. So that's kind of achieving our first learning target, being able to simplify a radical expression by adding or subtracting like terms. We're just looking for matches under those square root symbols. And if there isn't a match, searching for a way to simplify the radicand. They may have a perfect square factor. Let's hit that second learning target. So, learning target 2. Example. Now instead, let's look at some products. Sure, let's do this one. No, we wouldn't have that. I'm sort of in a dream state, but we're not getting imaginary tonight. All right. nothing negative under the square root symbol. That would just be too chaotic. Just looking at two radicals multiplied by one another, right? We sort of covered the product rule. So the values in each of the square roots, to find the product of those radicals, you can just smush them together. They all enter under one roof. The -1 or the negative sign kind of hangs out. So this is just the negative square root of 6. But let's say we're finding the product of, right, root 12 and root 15. So this is my tip. This is an example of where it's important to simplify early and often. Right, maybe you don't see this immediately, but right, square root of 12 can be simplified. Right, this equals the square root of 4 times 3, or 2 root 3. Okay. Another thing you could be alerted to is that, right, 15 is the product of right, 3 and 5. So if we rewrite this, right, as 2 times 3 times the square root of 5 times 3, right, we're sort of catching or alarmed by the fact that if we simplify this now, we have 3 times 3 times 5, all under the square root roof. So we have a match of 3's. So 3 kind of leaves the little square root house. Right, so we have 2 times 3, root 5. So our product is 6 times the square root of 5. And that saves us the headache of perhaps multiplying 12 and 15 and having to find that 36 is a perfect square factor of that product, which would be, what is that? 144 plus 36, right? 180. Is that right? Something like that. But simplify it early and often to avoid kind of that more challenging numerical puzzle. Well, let's look at this example. This one's interesting. Again, a lesson in simplifying early and often. Let's say we have the product of the square root of 9 and root 3. Right, one could say, like, sure, this is the square root of 27. But that's not simplified. And ultimately, this question's asking us just, just simplify square root of 9. Okay, this would be 3 times root 3, and that is simplified. Yeah, so nothing really to do here. Now, I didn't really cover a good example of this, but just in general, let me come up with another one. Example. Things that just won't work out. 4 root 7 times 2 times the square root of 3. Okay, so just note that when taking the product of square roots, right, you can't multiply like things that are under a square root roof times things that aren't. You could jam them back into the square roots, but that's kind of defeats the purpose of what we're doing altogether. I wouldn't do that. So multiply numbers outside the square root roof, and then multiply. This is kind of a general truth inside the radicals. So this product will be right, 2 times 4, 8, square root of 21, and square root of 21 cannot be simplified. Boom. So that was a bonus example, but I think it covered something that probably needed to be covered in this video. Yeah, that's it for this one. Thanks for watching. Take care. Bye-bye.